You know, we see it everywhere, right? The concrete that makes up our cities, our homes, our infrastructure. But the process of making cement, its key ingredient, hides a massive challenge, one that's microscopic, relentless, and everywhere. So let's get into it, cement's dusty dilemma.
So, what do you think is the single biggest challenge here? I mean, your first guess might be the sheer amount of material, or maybe the crazy amount of energy it takes. And yeah, those are huge, but the most stubborn problem, it's something you can barely even see.
Yep, the answer is dust. And listen, we're not talking about a little bit of dust you sweep up at the end of the day. This is a constant, overwhelming blizzard of tiny, sharp particles. It gets into everything, clogs up machinery, and creates some really serious risks. So dealing with it, it's not just a challenge, it's absolutely critical.
And this goes way beyond just, simple housekeeping. Keeping this dust under control is crucial for three big reasons. First, protecting the health of the workers. Second, meeting some incredibly strict environmental laws. And third, making sure millions of dollars of equipment doesn't just grind to a halt. Seriously, the stakes here could not be higher.
Okay, so let's tackle the first big problem, the sheer volume of this stuff. I want you to imagine a relentless blizzard of superfine particles that just never ever stops. It coats every single surface, fills up the air, and your standard industrial gear, it's just not built to handle that kind of assault.
If you tried to use a conventional filter, it would clog up almost instantly. The whole operation would just shut down. So the engineering solution here is honestly pretty brilliant. They use these special filter bags coated with PTFE. You've heard of that. It's polytetrafluoroethylene. It's basically the same non-stick stuff you find in your kitchen cookware. Because it has that super low friction surface, the dust particles can't cake on. And what does that mean? The air keeps flowing and the plant keeps running.
All right, so you've got this massive dust problem. Now, let's add another layer of difficulty, shall we? How about some extreme, punishing heat? We're not just talking about a dusty environment anymore. This is a scorching hot one. And that creates a whole different problem, a fundamental one for material science.
See, to make what's called clinker, these are the little hard pellets that get ground up to make cement, you have to heat the raw materials in these gigantic kilns. We're talking over 1,400 degrees Celsius. That is incredibly hot. And the superheated air and dust that comes flying out of these kilns, it's literally hot enough to just burn up standard filter materials. Poof, gone.
So what do you do when your equipment just can't take the heat? Well, you engineer new materials that can. The solution here is pretty cool, specialized fiberglass filters. Because fiberglass is made from silica, it's non-combustible. It holds its shape and structure even at these insane temperatures, which is something a regular fabric filter just can't do. Then they treat these fiberglass filters with special high-temp coatings, and suddenly they can work flawlessly, even in what's basically a furnace.
Okay, so our engineers have figured out how to handle the crazy volume and the intense heat. But there's a third challenge, and this one isn't physical. It's a legal one, and it is tough. See, cement plants have to operate under some of the absolute strictest air quality standards of any industry out there.
Here in the US, this is all governed by the EPA's NESHAP standards. That stands for the National Emission Standards for Hazardous Air Pollutants. And let me be clear, this isn't just a friendly suggestion. It is the law, period.
And these rules are incredibly specific. Get this. For every single ton of clinker they produce, a plant is only allowed to emit 0.07 pounds of dust. Just let that number sink in for a second. Out of 2,000 pounds of product, less than a handful of dust is allowed to escape into the air. That's just wild. Meeting a standard that strict is, well, it's a massive engineering challenge. It means you have to push filtration technology to its absolute limit. There are no off-the-shelf solutions that are going to cut it here. You need the most advanced, top-of-the-line systems you can possibly get. So how in the world do these plants solve all three of these massive problems at the same time? Well, the answer isn't just one magic bullet technology. It's a really smart, integrated system where every single part is engineered for a very specific job, and they all work together to make modern cement production clean and, of course, safe. And this table really lays out the whole strategy perfectly, doesn't it? To handle all that dust, you need those non-stick PTSE coatings. To survive the crazy heat, you need that specialized fiberglass. And to hit those super tight emission standards, you need advanced filter media that brings it all together. It's just a perfect example of engineering a specific solution for each specific problem.
These are exactly the kind of behind the scenes innovations that literally allow us to build our world. It's this kind of thinking that ensures a fundamental industry like cement can operate safely for its workers, responsibly for the environment, and efficiently for all of us in the global economy.
It really makes you look at the world a little differently, doesn't it? So, the next time you see a concrete building or a bridge, think about all the invisible engineering that had to happen to make it possible. It makes you wonder, right? What other hidden innovations are all around us, quietly holding our modern world together?